Right, what I'm going to do now is I'm going to set the maximum power of the amplifier. We've set it to peak, but what we've got to do now is set it to 4 watts, so we're not overdriving the output stage. That's fairly straightforward. You apply the normal input voltage, but they specify 14.2 on the or 13.8 or 13.2. What do they specify? They do specify 1 voltage, which seems a bit odd. I think they suggest 13.2. But anyway, we're setting it to 13.2 anyway. That's what it's set to at the moment. We're going to adjust the amplifier now to try and get the channel 1 and channel 40 to about 4 watts. And the instructions are quite straightforward really. It says rotate L4 clockwise until you see 4.4 watts on the power meter. So we're running through a 10 dB attenuator here, which you can see here. We're looking for power on the right hand meter. So as it's a 10 dB attenuator, that's 5.7 watts at the moment. So I'm going to go in and adjust this core. So I'm just going to check I'm doing the right one, because I've never done one of these before. Once you've done them a couple of times, it becomes a bit of fay and you know what you're doing, but I've never worked on a CB radio before, so I'm a little bit scratchy on where everything is. But I have got a layout, an L4. I think I'm on L4 at the moment. L4 is the yellow core, so no, I'm not on the right core. So I'm going to transmit and wind the core in clockwise until I get 0.4 indicated on this meter here. So I'm going to wind in now. There we go, see it dropping back to, there's your 0.4. Okay, so release the transmitter, and then it says rotate L9 counterclockwise to obtain 3.8 watts. I'm going to go to 4 watts there. That's what most people are doing. So L9 is the other core. Well, there's 3 cores in this line, but L9 is the I think that's the white core. No, the green core. It's L9. I'm going to turn that counterclockwise to get 3.8 watts or 4 watts, but yeah, I think it's basically on 4 watts now anyway. But yeah, so let's turn it down to 3.8 watts anyway. So going anti-clockwise to bring it down. It's going up a bit. Oh, here it comes down, 3.8 watts. So there's 3.8 watts. Now when I'm going to go channel 1, and that's 3.8 watts, and channel 40 should be the same if it's balanced correctly. 3.70 watts. So yeah, we could bring that in probably slightly with this adjustment. 3.76. Channel 1. Yeah, we're not going to get it perfect, but it's that's how it's supposed to be set up. I think we'll leave it like that. I might be trying to screw a little bit more power out of it, but the most important thing is to keep the power balance between channel 1 and channel 40. Then we're moving on to the receive section next. Right, let's check the deviation. When I say check it, confirm that it's over deviating. I'm just looking at the pot, which is RV2 here, and it's fully clockwise. So what I'm going to do is the deviation test. Now what you can do is apply a tone to the microphone, or you can just, basically with the microphone gain full of volume, just shout down the microphone. We want a maximum of 2.5 kilohertz deviation. Any more than that and you risk bleeding over to the other channels. So you can either shout testing 1 2 or whatever you like, but it seems to be a fairly useful sort of term, shouting wallow, which is invented by one of the CB repair channels on the internet. He seems to use that a lot. Seems to work well because it's like a drawn out sound that would actually be very useful for modulation. So let's try it anyway. Let's try and see what we get. So testing 1 2. Well, straight away we got 5 kilohertz deviation. So our deviation is too high. So what I'm going to do is, somewhere here in all my bits and pieces I have a microphone calibrator. Here we go, a microphone calibrator that will generate a tone, and we can use that to set the level. So I'll just stick it in front of the camera. You can't see it, but it's just you just plug it in front of a sound calibrator, and it will it's used for a reference level. So this is generating 104 dB signal at 1 kilohertz into the set. See 4.7, 4.8, so we're over deviating by a mile. Again, lower the pot. Let's wind this down. Where are we? There we go. So here we go. Down, down. Come on. So what? 2.5 kilohertz maximum, very maximum. There you go. That's fine. So testing, 1, 2, 1, 2, 1, 2. Even still over deviating very slightly. I'm going to turn it down a little bit more. Get the screwdriver in. Testing. There you go. So that's good. The deviation is set correctly. We're not over deviating. I'm not going to run the risk of sort of like wiping anyone else out. Not that there's going to be anyone on the channel anyway. So the deviation's done, and then basically been moving on to the next step, which is probably RF alignment. Right, I'm going to do the receive alignment on the CB radio this evening. That involves measuring across a test point with a meter. This is the way it says it in the manual. You can do it with a Cybernet meter, but I'm not going to do that. I'm going to do it how it says in the manual. Now, I would like to point out that some people have commented that these meters aren't particularly good, or one particular follower of mine doesn't rate these meters. Well, I'd just like to point this out and how useful this meter is. This is a Micronta FET front end analog meter, basically. So it's got all the qualities of an analog meter, but it's got a very high impedance of about 1 meg. So I can, well, it's actually 10 meg, I think. Yeah, 10 meg on the DC range. So it's very high input impedance. Something you couldn't use an Ava or a Simpson like that. This is great for this. What I'm doing is I'm measuring across a test point and adjusting the coils for maximum DC voltage. So this is basically a sensitivity check, and I think we're just measuring across the AGC line. Look at the Roden Schwartz here, and it's showing the frequency. We're on frequency 27.79125 megahertz, which equates to channel 20. But I'm on 1 volt per division, and normally that would be off the scale. But because it's got an adjustment for 0, I can bring that back to 0. So any adjustment I make, if it goes up, you'll see straight away. Whereas normally, if you put that on a 1 volt meter, it'll be off the scale. So that's the really nice thing about these meters. We're not looking at voltage now, so don't think that we're looking. If you're looking at the 1 volt range and you see 1 volt, you're getting 1 volt. We're not, because our center 0 adjustment is wrong. If I disconnect the lead, you'll see, and it falls negative. Simply set it to 0 because the lowest input that the signal generator can produce, that's the DC level we're getting. So we basically put it to a null sort of thing. So I'm going to go through and adjust each of the transformers listed, and basically we're looking for the maximum DC voltage. So I'm going to try and bring this out of the way so I don't stick my hand in front of the meter. Let's zoom in a bit. Unfortunately, the bottom of my camera's broken as well, so it's a bit wobbly, so hopefully it should be fine once it's on the tripod. So go to the first winding. So we're looking for maximum voltage across here, so we're looking for the meter to go up. It's going down. It's gone up very slightly. Okay, so we'll move on to the next winding. Just checking my hand's not in the way. It's got very tiny amount. Just checking the signal generator is producing the right output. Third winding. Wrong way. That's gone up quite well. That's gone up quite a lot, hasn't it? Okay, that's good. That's a good gain. Okay, the next winding. Come up for just a fraction. Okay. Next winding. Quite a little bit as well, isn't it? So we're getting a bit of gain on the RF sensitivity, and the final winding. Okay, so what I'm going to do, I'm going to bring the RF signal down further, and we're going to go through again. So start from the same winding again at the beginning. Zoom you in a bit now so you can see a little bit clearer what's going on. So maximum deflection we're looking for. Just checking my frequency is correct, because this isn't a synthesized signal generator, so it's a little bit, can be prone to drifting a bit. 27.79125. The meter on it is actually extremely accurate, so I'm pretty trustworthy of that, and it's dropped off a couple of 100 hertz or something like that. So going through again. It's kind of a little bit more as well. This one's very touchy, this winding. It's good. Next one. So we're checking it's 27.79125, that's showing correct. That's our input frequency. That's dinner. Okay, next winding. Yeah, that's peaked. And the final winding. No improvement. So that's it. I mean, we've got a gain out of that. Well, it's always nice to see. It's always disappointing when it's as best as you can get it already. You know, you go in there and think you're going to get an improvement, and you don't. So that's working nicely. Pleased with that. Let's move on to the demodulator and all the other parts. Okay, so the demodulator section. There's one winding you need to adjust. So basically, I'm feeding in a 1 kilohertz tone into the front end on channel 20 with a 800 hertz deviation, so very narrow deviation, and it's saying adjust T12 for maximum. It says when rotating T12, 3 peaks will appear on the scope. Be sure to use the second peak. Okay, so T12 is down the corner here. Okay, that's a smaller peak. So come back. Yeah, so there's the first peak. This is the second peak, which is the one we're interested in. So there we go, that's basically all you do. Get the maximum amount of amplitude. Get it to trigger a bit more stably. Yep, so that's it. That's the end of the front end adjustment, I think. Apart from that, we've just a couple of settings to confirm that our power level's correct, confirm the sensitivity, deviation, things like that. So that should finish the calibration. Right, confirm that the squelch is working correctly. Seems to be working very well, very sensitive, and it does open the squelch when you've got it full, turned fully up. And so sometimes if they've been twiddled, they won't even open squelch up with just like a 1 volt signal in, which is ridiculous. So this is the final test. It says put in a 40 microvolt signal and just R3 for the estimated read S9, and it's just under S9. So we're going to just check that by adjusting RV3. Which I think I know where it is, but I'm going to just check. And that's this pot here. And then I'm just going to go back one more time, check the RF alignment, and then we'll go. So this should bring us to S9. Bit of a jumpy old pot. Let's give it a wiggle. The old wiggle. Okay, S9. Okay, so that's the meter set correctly, and I think what we've got to do really is just, as I say, going to go through one more time, check the RF front end, and then I'm going to box it up and see if I can get anyone on the internet, on the CB bands. Well, let's see what results we've got. Sensitivity. This will be the final test of the CB, I think. So injecting in presently a 0.5 microvolt signal into the front end, and we're getting a 23 dB synads. Let's take it down to the 12 dB synad reference point and see what signal we're putting in. Okay. And that is 0.2 of a microvolt, 0.199, and go down a little bit lower. It's about 10 dBm. It's all breaking through the noise now, but very sensitive, 0.177 of a microvolt. So that appears to be working very well, and it basically concludes the calibration of this CB radio. I should be able to put the cover back on and hopefully use it and be able to receive something on it after all this effort. But thanks for watching the videos. I know it hasn't been the most popular videos of mine because I know most people don't use CB radios anymore, but it was my first experience of a transmitter, and I've quite enjoyed tinkering around with this radio. Thanks for watching.